And welcome back. Today we get to work with section 4.4 on undetermined coefficients. And we'll be using what's called the superposition approach. So the idea that we're working with, we have a non-homogeneous DE. So basically, we cut it into two parts. We solve the homogeneous part of the non-homogeneous differential equation to find y sub c, and then we set up a hypothetical yp based on the right hand side. So a couple quick examples. We'll look at y double prime plus 2y prime. It's worth 2x plus 5 minus e to the minus 2x. So the first thing I'm going to do is find yc. So basically we're solving the homogeneous equation that's within here, y double prime plus 2y prime equals 0. So we go to our auxiliary equation, m squared plus 2 times m equals 0, and factor that and solve it. So then yc is c1 e to the 0x plus c2 e to the negative 2x. E to the 0x, of course, though, is just 1, so yc is c1 plus c2 e to the negative 2x power. So we've solved the homogeneous part of our differential equation. So next we're going to find yp based on the right side. Now, looking at the fact that I don't have any y just by itself, I have y prime, and in the polynomial portion of the right-hand side, my smallest exponent is a 1. That would mean then to get down to y to the first, I would need to have an exponent of 2. So we'll use a yp with unknown coefficients. We'll just call the unknowns a, b, and c. So yp, we'll use a x squared plus b times x plus c x e to the negative 2 times x. So we find yp prime 2ax plus b minus 2c x e to the negative 2x plus c e to the negative 2x. Yp double prime 2a, the b drops out. Then we have, let's see, plus 4cx e to the negative 2x. So we're just using the product rule like we did the previous step. Then we're going to hang on to this e to the negative 2x and differentiate that. So minus 2c e to the negative 2x. And differentiating c e to the negative 2x would be another negative 2c e to the negative 2 times x. So we'll do a little bit of cleanup on y double prime. So we'd still have our 2a. We'd have a minus 4c e to the negative 2x and a plus 4cx e to the negative 2x. All right, so we'll do a little substituting into the original. So y double prime, so that would be a 2a minus 4c e to the negative 2x plus 4cx e to the negative 2x plus 2 times y prime 2ax plus b minus 2cx e to the negative 2x plus c e to the negative 2x. And that's equal to, again, forgive my too big a writing here, the right hand side, pretend it's all on the same line, 2x plus 5 minus e to the negative 2x. All right, so we'll knock down these parentheses, find a couple like terms, and see what we can do with this. So 2a is just along for the ride, minus 4c e to the negative 2x plus 4cx e to the negative 2x. And we have plus 4ax plus 2b minus 4cx e to the negative 2x and plus 2c e to the negative 2x. And that's going to be worth the same right-hand side we had before, 2x plus 5 minus e to the minus 2x. We've got a couple of like terms that we can take care of here, though. Let's see. So we have the 4ax. We'll bring that along. Let's see, what else do we have? We had a plus 2a and a plus 2b. So we'll put that up there. So plus 2a plus 2b. Now for our e to the minus 2x's, let's see, we have a plus 4cx e to the negative 2x and a minus 4cx e to the negative 2x. Those will drop. Then we have minus 4c e to the negative 2x and plus 2c e to the negative 2x, so minus 2c e to the negative 2x. And that's equal to our same right-hand side that we've had all throughout this, which would be 2x plus 5 minus e to the minus 2x. So you might have noticed I kind of broke this into sort of teams. So we just look at the respective components. So 4a has to be worth 2, since those are both attached to the x to the first. So then a is a half. 2a plus 2b has to be worth a 5. Those were the only constants we had. And a is 1/2. So half of 2 is 1, 5 minus 1 is 4, so 2b is 4, so b is worth 2. And finally, negative 2c is worth negative 1, so c is worth 1/2. So recall from the previous page, yp we said was ax squared plus bx plus c e to the negative 2x. My apologies, cx e to the negative 2x. Make sure I denoted that correctly on this page. Yes. Now, the reason that we have this x attached here, you might have noticed we didn't make something that looked exactly like it. E to the negative 2x without another variable, that's already covered in yc. That would drop us out to a 0. So we had to attach an x. So y sub b, half x squared plus 2x plus half x e to the negative 2x. And yc from the previous page, we figured out was c1 plus c2 e to the negative 2x. So then our solution to this non-homogeneous differential equation would be c1 plus c2 e to the negative 2x. So that's the part that would give us the 0. And then we add on our particular solution that would give us the 2x plus 5 minus e to the minus 2x. So that would be adding on half x squared plus 2x plus half x e to the negative 2x. You may also wonder why we didn't attach a constant here in our hypothetical yp. That has to do again with what yc looked like. We already had a constant. Same thing here, we already had an e to the minus 2x. Alright, so look at one that involves getting to play with a little bit of trig, but same idea that we were working with before. So this next one we'll do a y double prime plus 2y prime plus 2 times y is worth sine of 3x. And this time they give us some initial conditions. Y of 0 is 2 and y prime of 0 is 0. So not only will we be able to find our particular solution, we'll also be able to find c1 and c2. So as before, we start by solving the homogeneous, in other words, finding yc. So we just let y double prime plus 2y prime plus 2y temporarily equal 0. Work with our auxiliary equation, m squared plus 2m plus 2 is 0. This one, completing the square, would be probably the fastest way to go. So we'll add 1 to both sides. So m plus 1 quantity squared is negative 1. So m plus 1 is plus or minus I. So m is negative 1 plus or minus I. So then yc is worth c1 e to the negative 1x, or just minus x. Cosine of coefficient of I is a 1, so 1x, or just x. And we do the same thing with sine, so c2 e to the minus x sine x. So once we have that in hand, we find yp based on the right hand side. So since we have a sine as a result, and sines and cosines are derivatives of and integrals of one another, our hypothetical yp is going to involve both. So we'll have a cosine of 3x plus b sine of 3x. So yp prime, negative 3a sine of 3x plus 3 times b times cosine of 3x. Yp double prime then, derivative of sine of 3x will be 3 cosine 3x, so negative 9a cosine of 3x. Derivative of cosine, negative sine, so minus 9b sine of 3x. So then we go back to the original and just plug in what we know. So y double prime, we'll replace him with this guy. So negative 9a cosine of 3x minus 9b sine of 3x. There's our y double prime. Plus 2 times y prime. Y prime, negative 3a sine of 3x plus 3b cosine of 3x. I'm not going to fit this all on one line, so we're just going to wrap it around. So plus 2 times yp, a cosine of 3x plus b sine of 3x. And that should give us the sine of 3x. All right, so let's sort of do a little bit of simplifying, and we'll put some things together. I'll fit what I can here, and then we'll have to flip. So our cosines, we have a negative 9a. I'll just check them off as I go. 2 by 3b would be plus 6b. And distributing our 2 plus 2a. All of those were attached to a cosine of 3x. As far as sine of 3x, we have a negative 9b. Distributing the 2, we have a minus 6a. And distributing the positive 2, we have plus 2b. Each of those was multiplied by a sine of 3x, and that should give us sine of 3x. So we can really make a nice 2 by 2 system out of that. We'll do a little cleanup inside first, though. So we'll do negative 9a plus 2a, negative 7a plus 6b, cosine of 3x, plus negative 6a, negative 9b plus 2b, minus 7b, sine of 3x is worth sine of 3x. So we get two equations out of that. Negative 7a plus 6b is equal to 0. We don't have any cosines on the right-hand side. Negative 6a minus 7 times b is worth the unwritten coefficient of 1 that was on the right-hand side. So we're just solving that little 2 by 2 guy. I have a tendency of squeezing too much into one spot, so I'm going to go ahead and bring that to the next page. So we have our just little 2 by 2 system here, negative 7a plus 6b is 0 together with negative 6a minus 7b is worth 1. So then we just pick a variable, eliminate it, and find the other guy. Let's see. So we'll eliminate, what did I pick? I'll just eliminate what I did. I dropped the b's last time, so I'll drop the b's. So equation 1, I'll multiply both sides by 7, giving me negative 49a plus 42 times b is worth 0 times anything is still 0. Multiply both sides of row 2 by 6. So negative 36a minus 42 times b is worth 1 by 6 is just a 6. So negative 85a is worth 6. So a is negative 6/85. And then we can just plug that in to find b. So 6b is worth 7a. So 6b is 7 by negative 6/85. So 6b is negative 42/85. Divide both sides by 6. And let's see, we'll get a little canceling there. So negative 7/85 is our b value. So then yp, we said, was a cosine x plus b sine x. Or 3x, my apologies. A cosine 3x plus b sine of 3x. So negative 6/85 cosine of 3x minus 7/85 sine of 3x. So then we can plug in what we know. Y equals yc from the other page. That was c1 e to the minus x cosine x plus c2 e to the minus x sine x, and plus yp minus 6/85 cosine 3x minus 7/85 sine of 3x. So early in the problem, they told us that y of 0 was 2. So 2 is c1 e to the 0 cosine 0 plus c2 e to the 0 sine 0 minus 6/85 cosine 3 by 0 is still 0 minus 7/85 sine of 0. Sine of 0 is 0. Goodbye to this one, goodbye to that one. So 2 is worth c1 cosine of 0 is 1, e to 0 also a 1. So c1 minus 6/85. So 170/85 plus 6/85 is our c1. So c1 is 176/85. Now they also told us a value of y prime. They told us y prime of 0 was 0. All right, so we'll go ahead and do a little bit of factoring of y. So y equals, we'll factor e to the minus x, leaving us with c1, which we know the value of, 176/85 cosine x plus sine x minus 6/85 cosine 3x plus negative 7/85 sine of 3x. So we'll go ahead and differentiate that. So we've got a little product rule happening here. So differentiating e to the minus x, I get minus e to the minus x, and I keep the second factor. Then we keep the first factor, differentiate the second factor. So that would be minus 176/85 sine x. And derivative of sine x is cosine x. So that was the product rule on this first part. The rest of it, we were just using just our derivatives. So let's see, cosine would be negative sine. So the minus and negative flips that to a plus. So plus 3/6=18/85. Derivative of cosine is sine of 3x. We already flipped it. Same deal here, minus 21/85 cosine of 3x. And they told us that y prime of 0 was 0 in this problem. So the 2 bits of information they told us. All right, so all of our x's are zeros. Our y prime is also a 0. So 0 is equal to minus e to the 0 times 176/85 cosine 0 plus sine 0. In my C2. Doing all this work to find C2 and I didn't put my C2 in there. C sub 2, C sub 2. Okay, my apologies. Embarrassing little error there. My C2 disappeared on me. C2 should have been attached to the sine x. That's why we're looking for what we're looking for. Okay. Plus c sub 2 sine of 0 plus e to the 0 c2 cosine 0 minus 176/85 sine 0 plus 18/85 sine of 3x minus 21/85 cosine of, and 3 times 0 is 0. Left side, nice pretty 0. Minus e to the 0 is a negative 1. Sine of 0 is 0. That drops off. So we have then minus 176/85 cosine of 0 is just a 1. So e to 0 is 1. 1 times c2 cosine 0 is just c2. Sine of 0 drops that off. Sine of 0 drops off. Minus 21/85 times 1 is just minus 21/85. So 0 is c2 minus, they both have 85 downstairs, so 197/85. So c2 is 197/85. So that's enough to make our full equation then. Yeah, I'll try and sneak it in down here. So now I can say y is equal to c1. We know that value. 176/85. E to the minus x cosine x. c2 plus 197/85. E to the negative x sine x. And we already found our a and b earlier in the problem, minus 6 85ths cosine of 3x minus 7 85ths sine of 3x. So that would give us all of our solutions. That's the one curve that has all of the properties that we want, including going through 0, 2, and having a horizontal slope at y equals 0, or x, pardon me, at x equals 0. All right, so for some problems to try out in 4-4, I would recommend 1 to 39 on the odds. If you have questions, please get in touch. Otherwise, I will see you next time. Stay safe out there.